Hello, Internet. I'm back today again with another one of my inventions. You'll see I'm wearing my stylish Hawaiian shirt here. The reason for that is actually because I've attached some sensors to the back of it. So I've created this shirt in order to detect your posture, and then through this application I wrote, tell you through notifications when it's currently good or bad, so you can, adjust yourself. And, if you're not paying attention, you're focused on something, you get an alert and just tells you to fix your position a little bit. Just to give a demonstration really quick. So I'm standing here and I start to lean forward a bit. And it tells me to sit up, so I adjust that. And it fixes itself. This also runs in the background, so as I mentioned, there's notifications. So if I lean over again, you'll see a notification pop up telling you to sit up here. It's a little blurry, but you get the gist of it. If I adjust it again, automatically disappears. So on top of that, I also wanted to design this so that it worked while I was moving. Say I walk a lot and I end up going a lot of places and I have that general slouch as I walk around. So it also detects movement. I can tell when you're moving around, you see the moving thing just activated. And while you're moving, still determines your posture. So if I start to slouch over, you can't see it because I'm filming right now, but it'll actually detect and tell me to sit up. So I adjust the position again, and it goes back to good posture. And of course, if I stand still while I'm walking, give it a second, it'll determine I'm sitting still again. So all of these work as well when you're sitting down. Basically, any kind of upright positions, it'll all work. So I've taken the shirt off just so it's a bit easier to record. But the layout's actually pretty simple. So I mentioned there's sensors on the back. These are actually accelerometers that I've taped on. I tried a couple different approaches like Velcro and things of that sort. But I found that tape worked the best for keeping them at the correct angles and kind of flat to the shirt itself. So these are just two accelerometers that just give you the XYZ acceleration in place. And I've soldered the wires together with some nice little clips here so it all just kind of connects in the same spot. And these are both running into this box that I've laser cut here. Inside of the box is an Adafruit feather. So it's sending the XYZ signals from both of the sensors into this feather, and then the feather is serializing that data and sending it over Bluetooth to whatever the connected device is. The idea for this was that I wanted it all to be wireless, so it didn't have to be connected to a computer. So the data gets sent to the phone actually, and then on the phone, the application runs two different classifiers on the data to determine the posture and the movement. So I actually took this data and trained it in Python using scikit-learn, and then using a transpiler, converted it over to Java classes that can do the actual classification step with the weights that have been trained. So then the XYZ data is sent for posture at every moment, and for every moment it determines what the posture is at that moment, and then I actually take an average of that over some amount of time so that like if there's some outliers, it doesn't flicker of that sort. The time I'm going with is every 2-second intervals. And then for the movement, it's also taking those 2-second intervals, and then it's extrapolating from that the difference between the maximum and minimums of all those values to get across that range how much movement's occurring and determining if movement's occurring in that time segment to some significant amount. And that's all, of course, trained on a classifier so that it's a lot more generalizable, a lot more robust than if I tried to hard code all these values in and use heuristics of that sort. And actually for the posture data, what I'm actually doing is just providing the raw XYZ values from both of the sensors. I found I did some experimentation with like doing cross products or doing like differences across of them between the two different sensors or trying to do angles, but I found that just the raw XYZ values from both actually worked best for accuracy and classification. So that's the code side and the hardware side of things. Yeah, it's when I explain it all, it seems pretty simple, but it took a bit of effort, a lot of soldering, a lot of fabrication, figuring out the best way of connecting all the sensors up. But I think it works pretty well, and the real goal was to make it work while walking, and that works. So I'm pretty proud of it. Thank you very much for watching.